Vectors in 3D, 3D basics. When we move into 3 dimensions, we need to introduce a new direction. We add a new axis, the z-axis, to the existing x and y axes that we use in 2 dimensions. Consider the diagram below. Here we can see an axis formed by a left hand and an axis formed by a right hand. It's doubtful that you will ever have a question where this is an important distinction that needs to be drawn, but it is usual to work with what is known as an orthonormal right-handed base. So, like this one. As shown on the right in the diagram, if we draw the x and y axes in their normal 2D directions, we draw the z-axis coming out of the page. So when considering coordinates, we have x, y, and z coordinates. When working with vectors, we have I and j as we did with 2D, and then we add the vector k, which is a unit vector in the z direction, the positive z direction. So I is a unit vector in the direction of the positive x-axis, j is a unit vector in the direction of the positive y-axis in the usual way, and now we have k, which is a unit vector in the direction of the positive x-axis. As a natural extension of what we know for 2D, the midpoint of x1, y1, z1 and x2, y2, z2 is just given by averaging the x-coordinates, averaging the y-coordinates, and averaging the z-coordinates. The distance between these points is an extension of Pythagoras' theorem in 2D into 3D. This is very easily proven. For a vector v, which is a, b, c, the modulus or magnitude of the vector is mod v is the square root of a squared plus b squared plus c squared, and of course that's just an application of this distance formula where one of the points is the origin. The scalar product holds. The scalar product formula, as before, is a dot b is mod a mod b cos theta, where theta is the angle between the two vectors. So theta is the angle between the vectors. Now we're in 3D, so if we do a1, a2, a3 dot b1, b2, b3, then we get a1 times b1, a2 times b2, and a3 times b3. As in 2D, the scalar projection of a on b is a dot b divided by mod b. And of course we know how to calculate a dot b, and we know how to calculate mod b.